so we've got that taken care of. How about this one? The top and the bottom are my parallel lines. So let's first try to focus on just the x. If these are my parallel lines and this is the transversal, what type of angle pair relationship do we have between these guys? Alternate interior, which we said alternate interior are congruent. So to solve for x, we're going to take 4x and set it equal to 52. So what does that get us? 4 goes into 5 once, so 12, so 13. X is equal to 13. Then how can we get the y? Not a linear pair. Colin, what are you thinking? Owen?
Oh, you can set 3y plus 2 and plus 52 is equal to 180.
Oh, so you found the triangle. I wasn't even going there. You found this triangle, right? And we know that all three angles should add up to 180. That's a very good point. This is where I was going. I was thinking if I make this my transversal, what should be true about this angle and this angle?
90 degrees.
Yeah, it should be 90 degrees because they should add up to, like, so if I totally ignore, can I delete out this angle right there? Right, so does everybody see how we have consecutive interior angles right here? So these should add up to 180 degrees. Since this is 90, then I know that these two combined should be 90 degrees. Does everybody see that? So 3y plus 2 plus 4x should equal 90. What did we just say x was? 13. So 4 times 13 is 52 plus 2 plus 3y equals 90. So 3y plus 54 is equal to 90. I'm getting really small. I should go up here. So subtracting 54 from 90 is going to be 36. So 3y equals 36. I'm moving up top here. So y is equal to 12. Your answer there. And then the last algebra, we've got parallel lines, 3 of them, 3 sets. So I got a parallel line here, parallel line there. I don't think that top parallel line is going to help me with anything. So I'm actually just going to get rid of it so I don't get confused by it. All right. What corresponds with 60? 3x. So let's set those equals. So 3x equals 60. So x is equal to 20. That's one of my answers. What's the relationship over on the right-hand side? Consecutive interior, which we said are going to be supplementary. So 5y minus 5 plus 135 is equal to 180. Combining like terms, 5y plus 130 equals 180. 5y equals 50. So y is equal to 10. Good. All right, so we got our algebra down, hopefully. Or I could have just subtracted 135 from 180 and set it equal to that. Whatever move you prefer would work. Okay, so now let's get into proof world. Are you ready? Here we go. We can do this. So now what's going to happen is in our 2-column proofs, we're going to be given parallel lines. And remember, from when we did our proofs in Chapter 2, we were looking for key vocabulary words in that given. And sometimes, I think it was the bonus problem on your test, the key vocabulary word was the upside down T, which meant perpendicular. So now, in this case, my key vocabulary is my parallel line symbol, which is just an 11 or parallel line. So I am told that line AB is parallel to line CD. So if I look over here on the diagram, this line's parallel to this line. So if you want to do a little bit of marking, put little arrows, to show that they are parallel to each other. And what else are we given? Well, we're given that angle 1 is congruent to angle 3. So I'm going to put little congruent arcs in 1 and 3. Okay, so now we've got a bunch of theorems that we just got from 3.2. We have the theorem that says if we have parallel lines, then we know that corresponding angles are congruent. If we have parallel lines, then we know alternate interior angles are congruent. If we have parallel lines, then we know we have alternate exterior angles that are congruent. And if we have parallel lines, then we know that we have consecutive interior angles that are supplementary. Those are all of our if-then statements to work with. So again, we have our given. So if you have not yet filled in your given, we got our given. My key vocabulary word is parallel. So I'm going to make that my hypothesis. So if parallel, oh, this is nice. The left side's already filled in for us. Why? Oops, not even. Oops. We're not at if parallel. I didn't even pay attention. Why is 2 and 3 congruent to each other? They're vertical. Good. I was jumping the gun. So if vert angles, then congruent. Right? We're given that from the diagram. We can say, well, they're vertical angles, so we know that they're going to be congruent. Okay. We're not even at the parallel part. What else is next? So they have 1 congruent to 3, 2 is congruent to 3. Then why is 1 congruent to 2?
Because 1's congruent to 3.
Yeah, what property lets us do that? Transitive property, right? We can take out the link of the 3, and what are we left with? The 1 and the 2, so that's a transitive. You're going to have a lot of transitive happening in these proofs today. Transitive property. All right. If I were doing this proof on my own, line 4 would have been my line 2. Why are 1 and 4 congruent to each other? What are they from over here? They're alternate interior, aren't they? So if we have parallel lines, then alt int angles congruent. That's why sometimes it's easier just to do the proof yourself instead of trying to follow someone else's logic. I would have went there first and then pulled all the other stuff, but that's okay. All right, so now looking at what we have on that left-hand side, we just said that 1 is congruent to 4, and up here 1 was congruent to 2. So why then is 2 congruent to 4? What just happened between the reds? Transitive property again. We took out the 1s. Okay, so you're just trying to link and match everything up with each other. All right, let's do the last 2. Oh, again, the left side is filled in for us. I should have gotten rid of those left sides. That's okay. We'll try to follow along. All right, given. What are we given? We're given parallel lines. We don't have any vertical angles up there, so that's great. I don't have to do anything with vertical angles. We don't have any linear pairs, so let's see what we got. So why would 1 be congruent to 3? Alternate interior again. So if we have parallel lines, because that was our key vocabulary up here, so we were given that A is parallel to B. Well, if A is parallel to B, then I know 1 and 3 have to be congruent because they're alternate interior. So if parallel, then alt int angles congruent. Why would 1 and 2 be congruent to each other? Corresponding, good. So if C and D are parallel to each other, then they have to be congruent. So if parallel, then corresponding angles congruent. So then look at what we have. So 1's congruent to 3, 1's congruent to 2. So why is 2 congruent to 3? Transitive, good. Transitive property is probably going to be your best friend. Taking out the link of the 1s, right? Though technically it should have been 3 to 2 and then a symmetric property, but we'll go with it. All right. Okay, and then for the last one, we're given angle 1's congruent to angle 2. So 1 is congruent to angle 2. Okay. So how do I then know that those lines are parallel? What's the angle relationship between 1 and 2? Corresponding. So can you give me an if-then statement that would then tell me that they're parallel to each other? Yeah, good. So if we're just doing the converse. So if corresponding angles congruent, then my lines must be parallel. There's no A and B up there. Oh yeah, there it is. I just wrote over the A. So now if I know that A and B are parallel to each other, why do I then know that 5 and 7 are supplementary? Good. So as an if then, so if parallel, then consecutive int angles sup. Okay. All right. I need to take a look at the homework and see. Oh, I do have all the left sides. All right. Maybe that'll be a blessing in disguise.